Acceleration examples. This is the second part of the acceleration PowerPoint. Acceleration example number 1. Ball moving at a constant acceleration of 2.0 meters per second squared. If the ball started from rest, what will be the speed of the ball after 3.5 seconds? Now there's two ways of doing this. Number one, we can think about what acceleration is. It is change in velocity over time. So 2.0 meters per second squared means that the velocity is changing in the positive direction by 2 meters per second each second. So if it starts from rest, then it has a zero initial velocity and it's going to go positive 2 meters per second each second. So after 1 second, it's going to be moving at 2 meters per second. After 2 seconds, it's going to be moving at 4 meters per second. 3 seconds is going to be 6 meters per second. And then notice 3.5 seconds is another half of the acceleration, so it's going to be another 1. It's going to be a total of 7 meters per second. Now the other way to do this is to figure out what we know, what we're looking for, what equation will get us from what we know to what we're looking for, and then to solve. We know that the acceleration is going to be 2 meters per second squared. We know that the initial velocity is going to be 0 because it says here it starts from rest. And then we know the time, which is 3.5 seconds. So we know the acceleration, the initial velocity, and the time. What are we looking for? It says the speed of the ball after 3.5 seconds. Speed after means final velocity. So we're looking for the final velocity. So what equation gets us from what we know to what we need? Final velocity is going to be equal to acceleration times time plus the initial velocity. Let's plug in what we know. 2 times 3.5 plus 0, and that gives us 7 meters per second. So that gives us another method in order to figure out what the final velocity is going to be, because oftentimes on tests you don't have somebody over your shoulder telling you whether or not you have the right answer. So if you could figure out the answer one way and then figure out the answer using a different method, and both of those methods are correct, and you get to the same answer, then you can be more confident that your answer is correct. Example 2. Ball is thrown down at 8.0 meters per second. Knowing the acceleration due to gravity, how fast will the ball be moving after 2.6 seconds? Okay, now we know that the initial velocity is being thrown downward at 8 meters per second. Now since it's down, then that means the initial velocity is going to be negative 8 meters per second. We also know the time, 2.6 seconds. The acceleration due to gravity, and now that's a number you're going to have to know off the top of your head for the tests. The acceleration due to gravity is negative 9.8 meters per second squared. I'm not going to give you that on the test. You're going to have to know it. So what equation gets us from what we know to what we need? By the way, what do we need? How fast will the ball be moving after? Fast after, that's final velocity again. So final velocity is going to be equal to acceleration times time plus the initial velocity. We're going to plug in what we know. Negative 9.8 meters per second squared, that's the acceleration, times time, which is 2.6, plus a negative 8 meters per second. And then we find that our final velocity is going to be negative 33.5 meters per second. Example 3. A car moving at 30 meters per second can stop at an acceleration of 12 meters per second squared. Reaction time is about 0.8 seconds. If a deer jumps out in front of the car, how long will it take to stop the car? Well, we know the initial velocity. The initial velocity is given right here to be 30 meters per second. The acceleration is 12 meters per second squared, but this is a little bit tricky because it says it stops. Now, just because it's slowing down, that does not mean we automatically have a negative acceleration. But if it is slowing down, then that means the acceleration and the velocity are in opposite directions. Since we already know that the initial velocity is positive, then that means the acceleration has to be in the opposite direction, so it's going to be negative 12 meters per second squared. The final velocity, well, if we're going to stop, then that means our final velocity is going to be 0 meters per second. Now what's the time? It says here that we have a reaction time of 0.8 seconds. This is a little tricky because that's not the time we want. We want to figure out how long it takes to stop. While we're reacting, that takes 0.8 seconds. The time it takes to stop, that's actually what we're looking for, and then we're going to add that to our reaction time to figure out the total time. So we have initial velocity, final velocity, acceleration, we're looking for time. That's going to be final velocity equals acceleration times time plus initial velocity. Plug in what we know. We got 0 equals negative 12 times time plus 30. Subtract 30 from both sides, and then divide by negative 12, and that gives us a time of 2.5 seconds. Now that's not our total time, that's just the time it takes to stop. While we are moving at a constant speed, we are reacting 0.8 seconds. So the total time is 2.5 plus 0.8, which is 3.3 seconds. Here's a free fall example. You're on top of a cliff that's 150 meters above the surface of water. You drop a rock off the cliff, how long does it take for the rock to hit the ground? Now this problem only has one number in it, that 150 right there. But from the problem we can interpret more. The initial velocity, when you drop an object, the object is sitting still. So when you let go, initially it's moving at 0 meters per second and then it speeds up from there. The acceleration, since it's an object that's falling, it's going to be accelerating with the acceleration due to gravity, which is negative 9.8 meters per second squared. The displacement, you're on top of a 150 meter cliff, but your displacement's not 150 meters, it's negative 150 meters because it is moving downward. The displacement is downward. Think about it like this. The rock is going to start at a position of 150 meters. It's going to end at a position of 0 meters. Final minus initial, 0 minus 150 gives you negative 150. And the time is what we're going to be looking for. Now to find time, we're going to use displacement equals 1/2 times acceleration times time squared plus the initial velocity times time. Plug in the information we know, negative 150 is going to be equal to 1/2 times negative 9.8 times time squared plus the initial velocity, which is 0, times time. Now that term is going to go away because it's being multiplied by by 0. So that leaves us with time squared is going to be equal to negative 150 because we took this negative 9.8, divided it by 2, or multiplied by 1/2, and then took it to the other side. So negative 150 divided by negative 4.9, that gives us 30.6. You see here that if we didn't have that negative on the 150, then we would have had a negative time here, a time squared. And you know that anything that's squared cannot be negative. So when we square root it, we would have got an imaginary number, which would have been a problem. However, we didn't get a negative, so we square root both sides. Square root of 30.6, that gives us a time of 5.53 seconds. Now technically, when you square root an answer, you get two answers. You get a negative and a positive. The negative actually does mean something, but we're going to talk about that later. For now, we're going to be dealing with future time, so it's going to be positive 5. Same problem, but now we want to know how fast it's going to be moving when it hits the water. Notice we have the initial velocity, acceleration, displacement, and we're looking for the final velocity. The equation we're going to use is final velocity squared equals initial velocity squared plus 2 times acceleration times displacement. Plug in the information that we know. We got 0 squared, and that's going to be added to 2 times negative 9.8 times negative 150. We get final velocity squared is going to be equal to 2940 meters squared per second squared. Then we square root both sides. And again, we get two answers, negative 54.2 and positive 54.2 meters per second. So the question here is which one is right? Well, hopefully you realize that when we drop an object, it's going to be moving downward, which means the velocity is going to be downward. That means the velocity should be negative. Again, that positive does have a meaning, but we're going to talk about that later. So negative 54.2 meters per second is going to be 54.2 meters per second downward.